Okay, a question like that. So all will be objective type. I mean, MCQ type will be there.
Sir, how many questions will be there?
That I don't know also. I also don't know how many questions are there. I think for minor one, most probably only this type of MCQs are there. Okay, there is a 95% chance only. Okay. I think theories will not be asked. Okay. So prepare for MCQs and as well as theories also, because if you study the theories, then that MCQ problem can be a collection of theories also. Suppose 4 property statements are there. Okay, if you skip the theory part, suppose the properties of linearly eigenvalue and eigenvectors. Okay, some theorems can be like some MCQ can be a collection of 4 theorems. Okay, and one of them may be incorrect. So the question may be like this way: which one of the following statements are incorrect? Okay, so the properties you have to study. Okay, let us move forward. We'll see
The
one
time
example.
duration.
Can you repeat?
Time duration exam.
Time duration will be, it is around 50 to 60 minutes. Or maybe it will depend on the difficulty of the paper. If it is easy, then within 1 hour. If it is difficult, then accordingly the time will be set. Everything will be conducted by the coordinator. Once I get the information, I will share with you. But you have to check the LMS portal regularly. So anyway, we'll see one example. So how to get the quadratic form, how to get the canonical form from the quadratic form. Okay, so reduce the quadratic form to its canonical form and specify the matrix of transformation. Okay, so what we have to do, first we have to write the quadratic form, the matrix of the quadratic form. Okay, the matrix of the quadratic form. Then what we have to do, we have to find out the lambda values. Lambda values. From here we will get lambda 1, lambda 2 and lambda 3. Once we get these values, then the canonical form will be lambda x1, suppose x is there, lambda 1, x square plus lambda 2, y square plus lambda 3, z square. Now we have to find the matrix of transformation. That means we have to find the P matrix. Okay, for P matrix, what we have to do? We have to find the eigenvectors corresponding to lambda 1, lambda 2 and lambda 3. This is corresponding to lambda 1, this is lambda 2, and this is lambda 3. So here the lambda values are 2, 3, and 6. Okay. So corresponding to this lambda values, so we will solve this equation. Okay. Since 2 is the eigenvalue, 2 is an eigenvalue of this matrix, then it will satisfy this equation, and from this equation we will write the x values and the coefficient values, and from here we will solve. After solving this, we will get this as the eigenvector. Similarly, 2, 3, and 6. Okay, for 3, we will get this one. Eigenvector will be this one, 1, 1, 1. And after that, x3 will be corresponding to lambda equals to 6. So x3 we have got this one. This is actually transformation. Okay, this is alpha 3. And from here, x1, we will actually get this alpha 1 and alpha 2. After normalizing, alpha 1 actually x1 by the length of the matrix, length of the vector. Alpha 2 as x2 by, okay, so alpha 3 is x3 by x5. So the P matrix of transformation is nothing but, okay, this, if you write it in the column of a matrix. Okay, so you will collect the P matrix. P is actually alpha 1, alpha 2, and alpha 3. So from here, alpha 1, you will get this 1 by root 2, 0, minus 1 by root 2, 1 by root 3. Okay, so here it is minus 2 by root 6, then 1 by root 6. So that will be, that is what we have to find. Okay, matrix of transformation. Okay. So finding the canonical form, and after that we have to find the matrix of transformation.
How is alpha 2 0?
No, alpha 2 is not 0. Alpha 2 is this one, 1, 1, 1. Okay. So from this quadratic form, there is another property of quadratic form, which is known as the nature of the quadratic form. Nature of a quadratic form. Suppose Q is a quadratic form. Q can be written as this way. So this is a coefficient matrix. X is a vector. Okay, and X transpose is also a vector. X transpose and X are vector. X is actually this way, x1, x2, xn. Okay, so X transpose is actually x1, x2, xn. So this quadratic form is called this real quadratic form. Of course, we are taking real coefficients actually. Is a positive definite if all the eigenvalues of this matrix are positive. All eigenvalues are positive. And if it is negative definite, then it is negative definite if all the eigenvalues are negative, less than 0, strictly less than 0. Okay, in this case, for positive definite, strictly greater than 0. And positive semi-definite if at least one of the eigenvalue is 0 and others are positive. Okay, so all will be greater or equals to 0. Similarly, for negative definite, negative semi-definite, at least one will be 0 and others will be negative. And indefinite, if someone is if some values are some values are positive and others are negative, then it is not it is called indefinite. So if you take this example, for this matrix A, the eigenvalues will be 2, 3, and 6. So this is positive definite. This is the first case. Okay. Now if you take the second example, so all let me tell you that since this is a triangular matrix, okay, the left hand side is the since it is 4 by 4 matrix, so it is difficult to calculate the what is that determinant and all other cofactors and all other minors. So it will be lambda 1 plus 1. The characteristic polynomial for this matrix, for this type of matrix, will be this way. What is it called? Lambda plus 1. The characteristic equation will be this way. Lambda plus 2 and lambda plus 3, then lambda plus 4 equals to 0. So from here you will get this lambda equals to minus 1, minus 2, minus 3, minus 4. So all are negative. So this is negative definite. So this is case 2. Case 2. Negative definite. Okay. How about this positive semi-definite? If we have this type of matrix, okay, for a given matrix A, if we find the lambda values are this way, 1, 0, minus 2, these all are greater or equals to 0, and one of them is 0. So it is positive semi-definite. If for a different example, if we have like this way, all are less than equals to 0, but one of them is 0. So this is negative semi-definite. This is case 4, case 3, and this is case 5. Okay, 2 are positive, but one eigenvalue is negative. So this is case 5, indefinite. Okay. So we'll see one example how to find. Okay, the question will be like this way: reduce the quadratic form. Okay, reduce the quadratic form to its canonical form and discuss the nature of the quadratic form. So here there is no a square terms are not there. Okay, so in the diagonal it will be 0, 0, 0. Okay, so x1, x2 has coefficient 2. So that would be divided into this. Okay, half of this 2. Similarly, x1, x3 is 2. So it will be divided here. On the other hand, x2, x3, okay, it has coefficient minus 2. So it will be divided by half. So minus 1 and minus 1. So we are getting one symmetric matrix. Since it is symmetric, matrix of the quadratic form is always symmetric. Okay, because we are calculating it in this way. Okay, so that it becomes a symmetric matrix. Now we'll take the characteristic equation. Okay, we find that it is the lambda values are 1, 1, and minus 2. So 1, 1, and minus 2. Okay, so the canonical form will be like 1 into x square plus 1 into y square plus minus 2 of z square equals to 0. See here, square terms are not there in the canonical original quadratic form. Okay, Original quadratic form, it does not have any square terms. But here we are getting, in the canonical form, we are getting x1, x square plus y square plus z square.
Sir, how are the eigenvalues 1, 1, minus 2? Shouldn't be 1, 1, and 0.
No, no, no. Have you calculated?
By solving, we will get 1, 1 minus 2.
Yeah, you have to solve this.
Yeah, I think so. It's 1,
Sorry,
1,
this is
0.
actually wrongly written.
Huh?
No, I think it is correct. Not, this is actually determinant.
Otherwise, we have to solve, then we will get, sir, I think.
Yes, yes. Okay. Always think about this. So if you expand this determinant, what you will get? You are not able to find the eigenvectors, eigenvalues yet.
Yes, sir, I got it. It's fine. It's correct. It's correct.
Okay.
Yes, sir.
So lambda square minus 1. And here you will expand. Okay, if you expand this one, so if you expand this one, you will get, okay, one equation. After solving that equation, you will get this equation. You will get the values as this one. So the canonical form will be this one. Now you have to tell whether it is positive definite, semi-definite, positive definite, negative definite, or indefinite. Since we are getting the values are 1, 1, and okay, positive, positive, and negative. So it will be indefinite. Okay. Similarly, this point, example 4, it will be, again, it is negative, indefinite. Okay. And the canonical form will be written as this.
Sir, can we change the positions of lambda 1, lambda 2, and lambda 3?
For which?
So as we have written x square plus y square minus 2z square, can we replace minus 2 with 1 in any of x and y?
Okay, this is actually, if you want to, you can do it only if, just a minute, let me think. So for calculating this quadratic form, okay, lambda 1, lambda 2, and lambda 3, right, that question. Okay, then you have to mention the P matrix. Okay. Just let me think it. Okay, give me a minute. These are some examples. Okay, to determine the definiteness of the, also find the canonical form. That means you have to find the lambda values. These are some examples you can try. Now let me answer your question.
Sir, if we exchange the position of lambda 1 or 2 in the D matrix also there will be exchange, no sir. So
Yes,
indirectly
that is
again
what.
XYZ coefficients as that only, like similar.
Okay, can you repeat one more time?
So if we take if we exchange the positions of lambda 1 and lambda 3 in P also we need to exchange x1 and x3, no sir. So at last in D also the y and z positions will be exchanged. So in at last in the canonical form we get same coefficients for x and z.
Okay, right.
So
Yes,
even
sir.
if we change positions of x1 and x3 in D matrix, we will change the P matrix according to that.
Yes, we have to, because we are taking lambda 1 corresponds to x1.
Is your doubt clear?
Partially, sir.
Okay. So it's still not clear. Okay, just let me. Actually, I have another class from 11:30. Just let me. Actually, this question is incomplete. Whatever I have shown here, find the quadratic form. Okay. So you will never be asked only finding the this canonical form. Okay. This canonical form, okay. For this canonical form, we have to mention the corresponding associated matrix of transformation. Matrix of transformation.
Yes, sir. Then it will be clear that what coefficient we have to take with x and y and z.
Yes. We have to mention this P matrix. Sorry. Otherwise, this problem is incomplete. Okay, it will make confusion. We have to mention this P and P inverse. Actually, reduce the quadratic form into its canonical form. That means you have to use one transformation. Okay, we have to use one transformation, and we have to mention what transformation we are using. That what matrix, what will be our P matrix. We have to mention it. Okay. So that is why it has given you confusion. So I think now it is clear. So for here also.
Yes, sir.
Okay, for this also find the P inverse. Okay, this was just finding the nature. Okay, this is finding the nature. So our task is to find only the eigenvalues. From here we can tell the nature of the matrix, nature of the quadratic form. Okay, so I have given you some example for practice. So you can try it. Okay. If suppose the question is find the quadratic form and it's a matrix of transformation, okay, matrix of transformation, that is P matrix, okay, you have to find it. You have to find first, in order to calculate this P matrix, we need to find x1, x2, the eigenvectors x3, and after finding them, we have to normalize it. That means make the length 1. Okay, you have to make it 1. Alpha. You have to define alpha 1, alpha 2, and alpha 3. After making that length unit, that means unity, making the length 1, we will take this matrix. With the help of these eigenvectors, we will normalize them. Normalization is actually finding the value from 0 to 1. Okay. We'll make, this is called normalization process. Okay. So up to this, I think the discussion was minor 1 syllabus is over. In the next class, we will discuss some other topic, complex matrices. Okay. Up to today, we have discussed only real matrices. In the next class, we will discuss that is complex matrices. So if you have any doubt, you can ask me. There is a couple of some 10 minutes, 5 to 10 minutes is there. So from 11:30, I have another class. So I will stop here today.